NASA did not cancel the moon landing, but in February 2026, it admitted something almost as serious. The mission that was supposed to put astronauts back on the lunar surface was no longer a lunar landing mission at all. Artemis 3 was turned into a low Earth orbit test flight. The first landing role moved to Artemis 4 in 2028, and that one decision changed the meaning of the entire Artemis program. Because this was not just another delay. It was an admission that the original route back to the moon had become too risky to trust. For years, Artemis was presented as the program that would return astronauts to the lunar surface for the first time since Apollo. A new rocket, a new capsule, a new lander, a new era of exploration. But by early 2026, that story had collided with reality. The original sequence sounded simple. Artemis 1 would test the system without a crew. Artemis 2 would send astronauts around the moon, and Artemis 3 would take the final step and land them on the surface. But that neat progression hid a much bigger problem. NASA was trying to move from an uncrewed test flight to a fully integrated crewed lunar landing, with almost no room for a full rehearsal in between. That meant the Space Launch System had to work, Orion had to work, the commercial landers had to work, the docking sequence had to work, communications had to work, life support had to work, propulsion had to work, and the new exploration spacesuits had to work. Then all of it had to work together, under crewed mission conditions, with acceptable margins of safety. That was an extraordinary amount of first-time complexity for a program with so few intermediate steps, and NASA's own safety advisors had been warning about exactly that. In its 2025 annual report, NASA's Aerospace Safety Advisory Panel said it had repeatedly raised concerns about Artemis 3 and later mission risk postures. Then it made the warning even clearer. The panel said Artemis 3 carried a high-risk posture. It urged NASA to re-examine the mission, objectives and system architecture for Artemis 3 and the missions that followed. That is not the language of a minor scheduling slip. That is the language of a program being told its architecture no longer makes enough sense. And only days later, NASA effectively agreed. That is what made the February 2026 announcement so important. NASA was not just moving a date on a calendar. It was acknowledging that the original path to the moon had become too compressed, too fragile, too dependent on everything working the first time. And once you see that, the entire Artemis story starts to look different. Because the central failure was not simply that Artemis was late, it was that Artemis had tried to skip the slow, methodical build-up that human spaceflight usually requires. The hardware had been telling the same story too. After Artemis 1 returned from its uncrewed mission around the moon in 2022, NASA found unexpected char loss across Orion's heat shield. Engineers later concluded that gases inside the avcoat material had not vented as expected. Pressure built up, the material cracked, and some charred material broke away in several locations. That did not mean the Artemis 1 crew would have been lost if astronauts had been aboard. NASA said crew safety margins remained acceptable, but it did mean one of the most critical systems in the entire mission profile had behaved in ways engineers did not expect. And that matters, because when you are planning a program built around very few flights, every surprise becomes heavier. Every anomaly matters more. Every delay compounds everything behind it. That was the trap Artemis had built for itself. Not just delay, compression. A program trying to make one giant leap while still learning lessons that should have been learned earlier, and more safely. NASA's own February 2026 update made that tension visible. The agency said Artemis 2 hardware had been rolled back into the vehicle assembly building to troubleshoot helium flow issues, while teams worked repairs and range safety tasks ahead of upcoming launch opportunities. That detail was easy to miss, but it said a lot. Artemis 1 launched in November 2022. By early 2026, more than 3 years had passed, and NASA was still preparing for Artemis 2. That meant the real cadence of the program was far slower than the mission sequence had originally assumed. And when a program moves that slowly, every mission becomes heavier. The stakes rise, the pressure rises, the dependency on perfect execution rises. Then there was the landing system itself. The Aerospace Safety Advisory Panel said the challenge of getting SpaceX's human landing system ready for Artemis 3 was especially daunting because of its intricate operations, its complex concept of operations, and the challenges seen during the ongoing flight test program. That point matters because Artemis 3 was never just one launch. It was an entire chain of unproven systems that had to work together, and if any link in that chain slipped, the whole mission became harder to defend from a safety standpoint. This is where the Apollo comparison becomes impossible to ignore. Apollo did not jump straight from a small number of test flights to a fully integrated lunar landing. It built capability step by step. It tested spacecraft. It tested rendezvous and docking. It rehearsed critical mission elements before committing to the final landing attempt. NASA itself said the revised Artemis sequence was meant to reflect that Apollo mindset, one focused on system reliability and crew safety. That may have been the most revealing part of the entire reset, because NASA was not merely changing a date, it was changing its philosophy. Under the revised plan, Artemis 3 would spend about 30 days in low Earth orbit. Its purpose would be to rendezvous and dock with one or both commercial landers being developed by SpaceX and Blue Origin. NASA said the mission would include docked operations and integrated checks of life support, communications, propulsion systems, and the next-generation exploration spacesuits before any real lunar landing attempt. Only after that would Artemis 4 aim for the lunar surface in 2028. In other words, NASA finally inserted the missing step: the integrated rehearsal, the systems validation mission, the part of the program that probably should have existed from the beginning. That is why this moment matters so much. The moon mission was not cancelled, but the illusion that Artemis could rush straight to the surface without a more logical build-up absolutely was, and in some ways that made the announcement more important than a simple delay. It was the moment the public version of Artemis finally matched what the safety reviews had already been warning about behind the scenes. That leaves Artemis in a very different place now, not as a clean comeback story, not as a countdown to one triumphant landing date, but as a reminder that space programs do not only fail when rockets explode or missions are cancelled. Sometimes they fail much earlier, in the assumptions, in the sequencing, in the decision to treat complexity like confidence. In February 2026, NASA did not admit that it could never land on the moon. It admitted that the route it had chosen was too risky to trust, and that may have been the most honest step Artemis had taken in years, because returning to the moon was never just about building a rocket. It was about rebuilding the discipline to get there properly. This is infinite approach, and this is the engineering and science behind the missions that matter.